Here we go. So depending on what you've seen before, average rate of change is just finding the slope. In some earlier courses to show you this. And with the, I mean, if it's a line, think about a line. Now, that's not one of these questions, but what if I have the line, I don't know, how about y equals 2x minus 1? So let's see, I know that starts in the y-intercept, and the slope is 2, so here's this line. And if I wanted to find the average rate of change from 0 to 3, say, well, let's see. Here's where, let me change to different ink. So here's this point, which is actually what? 3, let's see, 2 times 3 is 6 minus 1 is 5. And 0, well, let's see, if x equals 0, that's 0, negative 1. And if I wanted to find the slope of that line, right, the slope, well, we already know, I mean, if you did the slope formula, right, 5 minus 1 over 3 minus 0, that's 2. We knew that, the slope is 2. So the average rate of change of a line, a linear function, is the slope. And what we have when we have curves like, let's see, wait, give me a minute here. So if I have this function, this parabola, x squared minus 1, and I want to find the average rate of change from negative 1 to 1, well, let's see, let's go to, I guess I can use a green. Here's negative 1, 0. And here's positive 1, 0. And if we want to do the average rate of change on that line, isn't that 0? And mathematically, we could say 0 minus 0 over 1 minus 1. Well, that's 0 over 2, which is 0. Of course, we can kind of see that. But then you pick another curve, a different curve on a different pair of points, a different endpoint on this parabola. Say like from 0 to 2, well, let's see, f of 0 is negative 1. We knew that. And f of 2, let's see, x squared is, 2 squared is 4, minus 1 is 3. So this point here is 4, 3. And we aren't, that is not a straight line. There's not a line, but if we just look at the graph of that does have a slope. So all we got to do is we say on the average rate of change, so the average between those 2 points in the curve is just the slope of that line, which is what? 2 minus 1 over, I'm sorry, it's 3. Messed that one up, sorry about that. Y is 3 minus negative 1 over 4 minus 0. Well, that's 4 over 4. That's a slope of 1. So the average rate of change of this curve on that interval is positive 1. And that's what you're doing. That's what all these questions are doing. It's just that sometimes they get, they're asking you functions that are a little nastier than parabolas and lines. Like, how about, well, what if we look at number 1? Now, I'm not gonna draw, because I tried to draw this. It almost looks like it's part of the curve. It's a line on the curve. But really what we're doing, well, tell you what, I can do B. Let's do B, because that shows up a little bit. I see a cubic function that's shifted up 1. So I know a cubic function looks something like this. And if I'm looking for the average rate of change between negative 1 and positive 1, that's what they're asking me. See, that's not quite the curve. It's close to the curve, but it's not quite. So if we evaluate what's f of 1, well, that's going to be my y2, right? So that's 1 plus 1 is 2. And f of negative 1, well, that's going to be negative 1 plus 1 is 0. So we've got these 2 points, 1, 2, and negative 1, 0, and we find the slope of that blue line, 2 minus 0 over 1 minus negative 1. Well, I think that's 2 over 2, so that average rate of change of that function on that interval is 1, because it's 2 over 2. And 2, 3, if we did 2, 3, well, I don't know what it is, something like this, we could find, it's going to be a much steeper slope, right? And if we could evaluate it, let's see, if we drop in, what's f of 3? Usually you do, what they'll do generally, they'll say, find the average rate of change of the function on the interval a to b. And b is the right hand point. So 27 plus 1 is 29. So we've got this point, or I'm sorry, 27 plus 1 is 28. And then f of 2 is going to be 8 plus 1, which is 9. So 28 minus 9 over 3 minus 2, what is that, 19? So that average rate of change is 19. It's growing much faster. And it's just an estimate. Where we're going to go right next is we're going to go start talking about the instantaneous rate of change. Okay, and that's what happens at a point. Is that enough? Do you want to do any more of these? I don't know. We can do them in the form if you want, or you think you're okay. You okay with the trig expressions? That can give people a hard time. Let me know. So now we're looking for the instantaneous, the slope of the curve at the given point. So instantaneous rate. And when we start looking at limits in section 2, they generalize this a little bit more, and that's where we'll be going with this. This lesson just kind of sets it up for you. So let's see, I'm seeing a parabola that's shifted down 5, and it looks something like this. So let's see, what's the y-intercepts? Plus or minus root 5. So that's like 2 point something, right? Negative 2 point something. So I don't know, something like that. So here's this curve. And it's on, they want at the point 2, negative 1. Let me get a different color here. At 2, negative 1. Well, it looks like I was close. So we want to find the slope of that curve at that single point. Now, I'll be honest with you, this is the only thing my son remembers about calculus, that you can find the slope with you only using one point. He was a good calculus student, just so you know, just saying. So how do we do that? Well, we need 2 points. So what we're going to do is we're going to come up here. Let's see, let me use this yellow ink and see how that shows up. We need 2 points. So what we're going to do is we've got this line here like we found before. And what it is, I don't know what this is, but I know this point here is 2, negative 1. And what I'm going to do is I'm going to come over a little bit. And I'm going to come over a little bit called h. So this point here is an x-coordinate 2 plus h, and it's going to be f of 2 plus h, whatever that point is, or f of 2 plus h. So that's my y2. It's kind of off my screen. I hope you can see that. And so now we've got a point. And what we do, where we go with this, is we slide. I can't do this on the software, but what we're going to do is we're going to slide that point. We're going to let. Sorry, I'm at school at the end of the day. They're doing announcements. So what you do is you say here's y2, here's x2, here's y1, here's x1, and we set up a slope. So we're going to do well. Let's see. We're going to do f of generally. We're going to say f of 2 plus h for this, minus f of 2 over x2. So let's actually, we know what x2 is, and it's at 2 plus h minus x sub 1, which is 2. So that works out to be just h in the bottom, right? And then, so now we can evaluate this. So let's see, what is, can I slide this down to give myself some room? Let's see here. Usually I can, yeah. So let's see, the function is x squared minus 5. So what is f of 2 plus h? Well, let's see, the function is x squared minus 5. So 2 plus h squared minus 5. And so we're going to FOIL it. Please don't make this mistake. Please don't say that this is 4 plus h squared, right? Because it's not a product. If this were a product, we could do that. What we need to remember is, and I say that because people do it all the time. You guys know algebra and maybe just need a little refresher. But when you square binomial, you got to write it twice in FOIL or multiply, right? So we're going to get 4 plus 4h plus h squared minus 5. So that's going to be what? Negative 1. So we're going to get what? We're going to get h squared plus 4h minus 1. So that's what f of That's the y sub 2. This is our y sub 2, and that's what we're going to drop in our slope formula up here. Now we're going to find f of 2. Well, we already know what f of 2 is. I mean, we could substitute it into the equation and find it, but we already know what it is because it's that point there, right? It's I don't know what I just did here. We know that that's f of 2, right? When x equals 2, y equals -1. So let's just drop those into the slope formula here. I guess I want to grab this. What do I want to grab? This. Can I grab that whole thing up? It looks like it's stuck here. 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 So y2, h squared plus 4h minus 1 minus y1, which was -1, all over. Remember how h2 plus h minus 2 canceled out? So that becomes h squared plus h, and that becomes plus 1 minus 1. That's gone, all over h. And then we can cancel out, so we can cancel out the h, right? And actually how you really want to think about it is you want to think I can factor an h out of the top. This avoids making mistakes. And then that h will cancel. So here's my slope formula. So what happens when those points line up? Right, when those points line up, let's see, can I drag that back down? When that yellow point slides back down on top of that red point, h is 0, right? The h is gone. It's on top of each other. So we'll say, okay, so what's the slope? Here we go. If that's it and h goes to 0, the slope of that curve at that point is 1, because 0 plus 1 is 1. And that's the process. And next section we'll formalize this a little bit. I'm going to do a couple more with you, okay? If you're good and you know how to do this, go ahead and jump in. You don't have to finish watching this video. Let me pause this for a minute, clean this screen up. Here, I think I'll try number 10, because that's a little different. So we know, I'm not even going to bother graphing if that's all right. I just know I got to find the slope, right? So what did I say? I said I'm going to do number 10. So x squared, so I'm looking for the slope at the point 1, -3, which is on that curve. We could check if we substitute in 1, we get -3, right? So this is going to be my x1, y1. Now we're just going to find x2, y2. And we're going to do, so remember we're going to go start at x equals 1 and slide a little bit over. So what is f of 1 plus that little bit more? Well, that's going to be x squared, so 1 plus h squared minus 4 times 1 plus h. Now let's clean that up. So remember, we're going to FOIL this, and that becomes 1 plus 2h plus h squared minus 4h, redistribute. Now we'll combine like terms, and I'm going to rewrite it so the h squared comes first. 2h minus 4h is -2h, and 1 minus 4 is -3. So that's the y2 minus y1. Well, we know y1 is that point right there, -3, all over now. And just like the last one, x2 is that 1 plus a little bit minus 1, right? Because that's x1. Well, that just becomes over h. So let me erase that just because I'm running out of screen real estate here. So I know that expression is divided by h, and this is the slope. And the 3 and the -3 cancels out. You know you're doing it right if that happens. And then I can factor an h out, right? So let me slow down. H squared minus 2h over h. I can factor an h out. The reason I want you to think about it this way is sometimes people hash out a denominator, but they can't do it on the other part. So if you think about it as a factoring, you'll come to making fewer mistakes. So that's my slope equation, and those points are going to line up. H becomes 0. What's the slope of that curve at x equals 1? Why, it's -2. Okay. Okay, how about something like number 14, which is when there's a cube? Whoops, let me undo. I just did too much. I deleted too much. Here, can I do that? There we go. So what did I say? Number 13? Yeah, let's do number 13. So I get an x cubed, and it's at 1. So first off, I want to find what f of 1 plus h is, that x value plus a little bit more. So 1 plus h cubed minus 12 times 1 plus h. Well, this takes a little more work. If we had to write it twice in FOIL when it was to the second power, now we're going to write it 3 times and expand it out. And I don't know, if you know Pascal's triangle or the binomial theorem and you want to use it, by all means, go ahead. I'm going to show you a little bit of brute multiplication here. I know that FOILs out to 1 plus 2h plus h squared. And then I'm going to distribute the 1 through, I'll distribute the h through. So distribute the 1 through, that gives me 1 plus 2h plus h squared. Now when I distribute that h through, right, h gets multiplied by 1, h gets multiplied by 2h, h gets multiplied by h squared. That gives me what? It gives me 1h, and notice how I'm lining up the like terms, plus 2h squared plus h cubed. So now if I line that up, I get 1 plus 3h plus 3h squared plus h cubed. And then I've got that negative 12 minus 12h from up above. So negative 12h minus 12, right? I hope I'm doing this right. My big mistake is I usually make a sign mistake and mess that one up. So the h cubed is positive, so I'm just going to come over here and write that there instead of lining it up here. Then I get a 3h squared, right, in descending order just to keep me sane. And negative 12h plus 3 is negative 9h, and negative 12 plus 1 is negative 11. So that is the y2. I'm hoping that this point, let's see if I can pull this in. See, am I recording? Yeah. Okay. Let me pull that. Yes, look at that. The y2 is, the y1 is negative 11. Oh, that's a good thing. I did make a mistake. So minus negative 11. So y2 here. y2 minus y1 over x2 minus x1. I hope you see that's just h, right? Remember, it's we substituted it in, what was it, 1 plus h? So 1 plus h minus 1. Oh, man, let's make sure I got that right. I think it is. Yes. Okay, so let's do some cleaning up now. Let's see, I'll try to move this all down so I can, whoops, not do that, Dan, here. Okay. Give me a second. So I know that h, so negative 11 plus 11, negative 1 plus 1. I can factor in h out of there, right? So h times h squared plus 3h minus 9 all over h. The h's cancel. Those points line up. The h disappears. That's gone, that's gone. My slope is negative 9. I throw that into Desmos and check and see. That's probably one of the hardest things that happen. I'll do the fraction one for you too. Okay, so one of these with a fraction can be hard for some people. We're going to do the same thing. We're going to say, hey, we want the, well, let's, you know what, since this isn't hard to graph and I get a little space here, I know 1 over x, the reciprocal functions look like this. And I know that I want the slope at negative 2, negative 1/2. So where is that? That's about here. So I'm looking for the slope of that curve right there. So I know it's going to be a negative slope, and that's a sign. But let's find out what it is. So again, we're going to say what's h of negative 2? Well, we know h of negative 2 is negative 1/2. Sorry about that. But I wanted to find out what's h of negative 2 plus a little bit. So that's going to be 1 over negative 2 plus h. I'm going to write it as h minus 2. That's y2 minus y1. So minus a negative y1 all over. Now you remember how that if we have h minus 2, let's see, how do we do this? Maybe I better write this out. Let's see. So x is -2. So h minus 2 minus -2. Here we go. That turns to plus plus. -2 plus 2 is 0, cancels out. That turns to plus. So we want to, here, let's go to my common denominator for the numerator is going to be 2 times h plus 2, h minus 2, right? So this needs to be multiplied by 2 over 2. This needs to be multiplied by h minus 2 times h minus 2 to get that common denominator. So let's move this up. So that gives me 2 plus h minus 2, because this is a plus, so that just becomes plus. I don't have to worry about changing any signs. And 2 times 1, right? And 1 times that. All over h. And, sorry. It's all over 2 times h minus 2, all over h. And then 2 minus 2 is h over 2 times h minus 2, divided by h, which is the same thing as multiplying by 1 over h. Right, because this is h over 1. If I'm dividing by a fraction, I take the reciprocal, right? So the h's cancel out. So my slope formula is 1 over 2 times h minus 2. Now we're going to let that point slide on top of that, so the h becomes 0. So isn't that going to be 1 over 2 times -2? So -1/4. And if you look, we said it was going to be a negative slope, right? And sure enough, yeah. So this would be a great problem to get some practice on. Do this one. I mean, maybe 16's the same in the book. You're going to see this a lot in the next section. And this is kind of, I'm going to ask you questions like this. It always comes out to be a fraction, and you got to get rid of it. Now, I say that always is a fraction. Usually it is. Okay. So give me a yell if you need some help with this. The only other thing, and I'm not going to show you this in this video, go look on in the lesson about or in the ebook about example 3, where they're saying you're doing numbers closer and closer and closer to the value. It works pretty slick. You know, I'm sure my math lab helps you do that. This video is long enough. It's 17 minutes. Give me a yell. Make an appointment with me if you want some help. I'd love to help you.